Assalamualaikum and good day, doctor. So this is the proposed hybrid algorithm. So basically, from the proposed hybrid algorithm, we need to identify which classifiers or machine learning algorithm suitable that we can assemble. Okay. As for the selected machine algorithm one is knife based. So this is the coding for knife based algorithm. So firstly, we import the libraries. Second, load the datasets. Third, handling the missing values. And then the FD types, where we want to see what kind of parameters that includes in this source code. And then we're handling the columns, where we identify which column is unnecessary that we need to drop. And this is the columns where we want to identify which columns is used for X and Y. And we train the datasets by splitting datasets and train the model, question knife base, and we predict where the accuracy is 0.76. And then we evaluate the model using the confusion matrix for knife based algorithm. And then lastly, we have the classification report for knife base. So let us try to restart and run all. Okay, so our final output, which is from the classification report. So the accuracy was 0.76 for knife based algorithm. So let us proceed with the second learning machine algorithm, which is logistic regressions. Okay, so here, different from knife base, we import the from sklearn linear model import logistic regressions. Previously, for the knife base machine learning algorithm, we import the from sklearn knife base import quotient knife base. So that is different between two machine learning algorithm. And then we load the data sets as usual, and then handling the machine values, handling the columns, and then okay, drop columns. We identify which columns is using the parameters for X and which columns is using the parameter for Y. Heavy rain. Okay, split the datasets, train the model, and then we make some predictions by calculating the accuracy, and we evaluate the model by using the coefficient metric as well. And then lastly, we have the classification report. So we go for kernel, restart and run all. Okay, so here we look at accuracy where it is similar with the first previous machine learning algorithm, which is knife based, and logistic regression showed the same level of accuracy, which is 0.76. And after that, after we identify the both machine learnings from knife based and logistic regressions, as they show the same number of accuracy percentage, and we decided to do the hybrid algorithm. So this is the purpose of hybrid algorithm, where we use the symbol from the voting classifiers. So this is the input libraries for knife based and logistic regressions. And then we load the datasets, test the datasets, split the datasets, and then after that we have the predict based on validation test for both algorithms, and we create a new matrix for knife based and logistic regression. And here is the train meta classifier, testing the datasets, combine the predictions, where we want to see if both of the Naïve and logistic regressions when they assemble? Is it similar with the previous result? And then we evaluate the hybrid. And then we have the ROC, receiver operating characteristics, and area under the curve, AUC. Then this one we have to import the one of the library different from the previous one, which are from sklearn.matrix, import ROC underscore curve, comma AUC. So generate a sample dataset for demonstrations, and then we make predictions on the datasets, compute ROC curve and AUC, and it shows the different kind of output from the ROC and AUC. And then we have the confusion matrix. So let us restart and run all to see how the assemble between Naïve and logistic regressions work. Okay, so this one. Okay, so this is the evaluation for the hybrid, where this is the accuracy for 0.84, and then for the ROC and AUC, as for the curve from the ROC, the Naïve shows 0.89 and the logistic regression shows 0.91. Then the coefficient matrix, we have to import the from sklearn.matrix, import coefficient matrix, and then we train the different kind of classifiers, Naïve and logistic regressions, and then we make predictions on test data, and then compute the coefficient matrix for each classifiers, which are Naïve and logistic regressions. And after that, we get the output for combined confusion matrix as for the model predictions. And then after that, we calculate the other evaluation matrix from both classifiers. And then from this calculate other evaluation matrix, we consider different types of percentages from the matrix, which are accuracy, precision, recall, F1 score, and AUC ROC. And after that, we have the model for the combined classifiers from both algorithms. And after that, we get the accuracy 0.825. Okay. And then this is for the other evaluation matrix from different kind of design. And then after that, we have to generate a classification report. So the accuracy was changed from 0.76 for both algorithm. For Naïve 0.76 and logistic regression 0.76, and hybrid algorithm, proposed hybrid algorithm shows higher accuracy rather than the previous number of percentages for the accuracy. So yeah, so this is the evaluate the model as the from sklearn.assemble import voting classifier is imported. So we use the voting classifier for our assemble method. So this is voting hard, and then train the voting classifier, make prediction, and calculate the accuracy. So finally, we've got the final accuracy, which are 0.83. So this one is 0 and 1. This is the recorded level of heavy rain, where 0 is the low measurement of heavy rain, and this one is a higher level of heavy rain. So this is the parameters as to identify the accuracy for the flood predictions in this proposed hybrid algorithm. Thank you.